there is tendency. But by controlled oxidation, when we say control, is that we are actually limiting the extent to which the reaction can proceed. So by controlled oxidation, we can stop at aldehyde. Is that okay? So primary alcohols are oxidized to aldehyde, which can also be oxidized to what? Carboxylic acid. Now, what oxidizing agents can you use? You can use potassium heptazodichromate, or you can use potassium. This one should be in acidic medium or acidic solution, or you can use potassium permanganate in basic solution. Any one of these will give us either an aldehyde or the corresponding carboxylic acid, depending on where you end the reaction. So if you have something like this, arrow CH2OH, this is a primary alcohol, all right, which I can also indicate with 1 degree alcohol. 1 degree alcohol means primary alcohol. So when this undergoes oxidation in the presence of the corresponding oxidizing agent, which is K2CrO2O7 in this case, it is going to give us, now I told you that this one should take place in acidic medium, it is going to give us an aldehyde. What is oxidation? We said that oxidation is the removal of hydrogen or the addition of oxygen. In this case, we are going to be removing 2 hydrogen from here. So if I remove 1 hydrogen from here, I remove this hydrogen from here, we have removed 2 hydrogen. So we said this reaction is by loss of what? Hydrogen. That is why it is what? Oxidation. You should take note of this. So if I remove oxygen from this position, remove hydrogen from here, 1 from here, 1 will be remaining here because there are 2 here. If I remove 1 from here, there will be none at this extreme end. So what do you think we are going to have? We are going to be having as the product arrow, there's CH, because we say we are removing 1 from here, and then HO plus maybe the water that was, the hydrogen that was removed, whatever. But this is the product that will be formed. This product, you can also write it as ROC double bond OH. This is an aldehyde. All right, so that is one way of actually converting alcohol to aldehyde, the synthesis. Is that okay? Now, for instance, you can have ethanol. What is the formula for ethanol? CH3 CH2OH plus the corresponding oxidizing agent in the presence of K2 CrO2O7. I told you that this must occur in acidic medium. What do you think will happen? We remove 2 hydrogen from here, remove 1 from here, right? I told you that you remove 1 from here, remove 1 from here. So in total, we are removing 2 hydrogen. This is going to give us CH3, CH, and then here will be what? O, plus this one we attack here, so it will give us water. So this here is called ethanol. So when ethanol is oxidized, it gives us ethanol. Now, if care is not taken, this ethanol can be oxidized to give us ethanoic acid. But if it is controlled oxidation, it is going to end at that junction there. Are you getting it now? Now, so that is that. However, ketones can be prepared by oxidation of secondary alcohol. Recall I said when primary alcohols are oxidized, what is formed? Aldehyde and ultimately carboxylic acid, depending on the reaction. whether it is limited to stop at that of what? Aldehyde. Is that okay? So now, oxidation of secondary alcohol. Secondary alcohols, the example is something like this. Now, you should know what secondary primary carbon center is by now. When you have only one hydrogen attached to the carbon carrying the OH is secondary carbon. Is that okay? So we have plus oxidation. We use the oxidizing agent K2CrO2O7 in acidic medium. Now this is going to give us something like this: aldehyde plus water. I mean, this is a ketone plus water. Now you discover something, that in this reaction we remove two hydrogen, one from here, one from here. Now when you remove these two hydrogen from here, a double bond will be formed. In elimination reaction, whenever I remove two atoms, a double bond is formed. So that's what happened here. Remove hydrogen from here, remove from here, a double bond is formed here. That hydrogen that we removed, two hydrogen plus this oxygen here from the oxidizing agent, gave us H2O. So here, what do you have here? Secondary alcohol. This is a prototype, and here is ketone. All right, now that is that. Now let us see an example of a reaction like that. You have let me put that here. I think there's another slide okay. You have something like this. It's very easy. This is what? 2-propanol or 2-propanol, yeah, plus the oxidizing agent. They'll be giving something like this in the exam, and they expect you to predict the product of this reaction. Hydrogen will be removed from here, hydrogen will be removed from here, double bond will be formed here. So it will give us a ketone, which is also known as acetone or propanol. So this will give us either 2-propanol, or you can call it acetone. Is that okay? So that is that for that case. Now there's what is called opinion oxidation or secondary alcohol. Now this one involves the treatment with acetone in the presence of aluminum tertiary botoxide. Now opinion oxidation has significant application in organic synthesis, especially in pharmaceutical synthesis. When you now come to the synthesis of steroids, right, like all those dihydroepidosterone coming to estrogen or the androgens, you see the significant or the application of opinion oxidation. Now what is generally opinion oxidation? Is more like conversion of secondary alcohol to ketone. The conversion of secondary alcohol to ketone in the presence of what? The presence of acetone, or when it is treated with acetone in the presence of aluminum tertiary botoxide. So for the opinion oxidation, this is a spelling: opinion oxidation. So you have something like this. Now this is a secondary alcohol plus CH3, C double bond O, CH3, a ketone. Now this is aluminum tertiary botoxide or aluminum tet botoxide, which is something like this. All right, you have it as this is not actually complete. Aluminum tet botoxide. Okay, now this is, so when this occur, what will happen is this group here will be oxidized. It's more like oxidation reduction reaction. This group here will be oxidized to ketone. Take note to this group here, you know, this is like the secondary alcohol before. Why this is a ketone? This secondary alcohol will be oxidized to ketone, while this ketone here will be reduced to alcohol. Is that okay? So that at the end of the day, this is what you are now going to have. This is going to give us R, C, R. Here will be oxidized to ketone. So you have C double bond O plus why this group here, you can see it, will be oxidized to alcohol. So here will be CH3, here will be C. So this will give us the corresponding alcohol. All right, so that is that for the Openia oxidation. You must take note that Openia oxidation uses acetone. This structure of acetone is a ketone. I've written it up before, acetone, in tertiary aluminum butoxide or aluminum tertiary butoxide. All right, to give us a ketone, and then the acetone will be reduced to 2-propanone. This acetone is reduced to 2-propanone. Now we are supposed to write the name on the, not on top, but because of space, that's the reason why I'm writing it on top. Is that okay? So that is that for that case. Now, oxidizing agent. Now there are so many oxidizing agents that are used. For instance, we have alkaline potassium permanganate, which is KMNO4. Told you that this one must be used in basic media. That is the reason why you have OH negative. Then you have chromic acid. That is where you have the potassium dichromate and so on and so forth. Should be used in what? Acidic medium. And then all right, so that is that. So this reagent is prepared in situ. This chromic acid is prepared in situ from this CrO3 with dilute sulfuric acid, H2SO4. So this one will give us H2CrO2O7. Or you can use sodium dichromate plus H2SO4. That will give us H2CrO2O7. Now when you see something is prepared in situ, what does it mean? It means as at when needed. All right, when you see something is prepared in situ, it means now the time when they need and that time they prepare them. All right, another oxidizing agent again is pyridine chlorochromate. Pyridine is C5H6N. Chromate is CrO3, and then chlorate. Chloro is this. So this is the structure of pyridine, chloro, and then chromate. Pyridine chromochromate in dichloromethane as solvent. Is that okay? So they may say list some oxidizing agents used in organic synthesis or in organic chemical reactions. You can say alkaline potassium permanganate, that is potassium permanganate in a base. The chromic acid, pyridine chlorochromate in dichloromethane solvent. Now, we said that this pyridine chromochromate is a special oxidizing agent. It's used to convert primary alcohol to aldehyde. Now, like I told you earlier, that primary alcohols, if they are converted to aldehyde, for instance, you have butanol. Let's say this is the structure of butanol. We said this butanol, when it is oxidized, right, if it is with PCC in dichloromethane, this structure of dichloromethane, is going to end in only aldehyde. Now, what do you think will happen here? Remove 2 hydrogens. That is oxidation. As at where that CH2OH is, remove 2 hydrogen. So here will give us CH2, here will be CHO. All right. Now this is butanol. Why this is what? Butanol. Is that okay? Now, this butanol, by other oxidizing agent, has the tendency of being converted to butanoic acid. To what? Butanoic acid. But with pyridine chromochromate, this reaction is avoided. So it will only end here, butanol. It cannot convert butanol to butanoic acid. That is why we say it's a special oxidizing agent. So whenever you see pyridine chromochromate, know that it's capable of converting aldehyde, primary alcohol to aldehyde without converting that aldehyde to the corresponding carboxylic